In the last lecture module, we focused primarily on background assumptions that serve to frame the formulation of theories of mental representation and or the evaluation of those theories in the literature. In this module, we want to shift our attention over to the second half of the material for this week, looking at 3 different prominent theories of mental representation. The first theory that we're going to start with is a theory that isn't covered in much detail in the reading. That's the intrinsic property theory, the similarity theory. We'll talk about what the similarity theory asserts. Then I'll try to motivate it by pointing out that it's plausible to suppose that the similarity theory, in fact, is a good theory for certain representational structures inside the human brain. Then we'll point to some general problems with similarity as a means for representing all sorts of different features of the world in the brain. And we'll finish by looking at the second category of theories, the theories that we'll cover in the next lecture. Use theories, theories that instead of focusing on properties of the state itself, focus on properties of the state's use in overall cognitive performance. Let's go ahead and pivot now then to theories about similarity as the source of representational content. Similarity theories hold that mental states represent some object or property or event or relation in virtue of sharing that property with the represented object or the represented property and so on. So if Homer is representing a green triangle out there in the world, Homer would do that by having a mental state that if we took our philosophical fMRI and put him in there, we would be able to visualize a little green triangle, represent a property of an object or an object by having those same properties. Hence, a state ST represents a green triangle if and only if that state ST is both green and triangular. Now, in this format, the theory doesn't look particularly plausible, and so we might think about the theorists who seem to advocate a similarity account, people like Plato and Locke, and wonder whether or not they were somehow tricked or deluded by residual dualist intuitions. But even those dualist intuitions aren't going to help you with the similarity theory. If you're trying to represent green triangles by having a non-physical mental substance state that is green and triangular, you're going to have a hard time there as well, since your mental substance has no dimensions, and so it can't have shapes or parts, etc. So we might be tempted to think that this is just a bad theory, that when Locke proposes it, for example, as the means by which our minds represent the primary properties of objects, he's just made a terrible mistake. However, the theory actually does look plausible when we look at certain aspects of our representational structures in the human brain. For example, pretty much all along the primary visual pathway, starting at the retina in the back of the eye, the lateral nucleus, all the way to the visual striate cortex. Our brains represent spatial dimensions depictively, that is, by using a retinotopic map. So, as the diagrams illustrate here, if you were to unfold your striate cortex, the cortex at the very back of your head, the first major junction in visual processing at the back of your head there, it would look like a pear, and it would have a retinotopic but distorted map, so that if you were looking at this woman here, the image actually would be projected upside down on the back of your eye because your lenses invert the scene, and it would go back to the visual striate cortex, and it would be represented on that cortex in this spatially distorted fashion, so that a triangle would really be represented by a triangular activation pattern in your striate cortex. Now, this isn't the only topographic map, the only spatial representation that we use in our brain to represent spatial dimensions. The motor cortex has a topographic organization as well. It's also quite distorted. This is what you would look like if your body actually conformed in its dimensions to the percentage of your motor cortex that's devoted to each of these areas. So obviously your hands and your face get much more than the rest of your body in the motor cortex. Similarly, in the sensory cortex, this is what you would look like if you were represented in the proportional fashion that the topographic map of your sensory cortex uses to represent your body and relative positions there too. So you might be thinking to yourself, wow, so maybe people should be similarity theorists after all. However, there are a number of well-understood problems with similarity as a general account for representational content. To represent some property or structure, that representational media has to be capable of manifesting those properties. Brains can't change color easily, or grow fur, or travel at the speed of light, and so their ability to represent those things can't be dependent upon their capacity to adopt those properties. Likewise, in order to make information explicit for inferences, the shared property has to have causal efficacy in the system, but the only system in which all the relevant properties in the world prove causally effective is the world itself, really. Finally, similarity isn't a good mechanism with which to capture abstraction, like categories. Does a red triangle represent acute triangles, red things, enclosed planar figures, etc.? So for instance, Berkeley tries to solve this problem by using language, by affixing names to collections of objects that share properties. It also helps us to understand why there can be a poop emoji, but there can't be an anti-disestablishmentarianism emoji. So in our next lecture, we'll turn our attention to our remaining two theories of mental representation, gnomic covariation and functional role semantics. While the similarity theory focuses upon a property of the state itself, using that property to explain its representational capacity and assign it content, gnomic covariation and functional role semantics instead focus upon the use to which that state is put within the overall system. How does it function within the system's cognitive economy? And it uses that information to assign content to it and ascribes that as the basis upon which it is capable of representing.